Hello, my name is Russ Festino, developer advocate for Algorand, and welcome to Blockchain for Developers, Part 2. Developers and tools, that's what we're talking about here. How do I build Algorand blockchain solutions? What are the Algorand networks? What is a node? What's the quickest way to get started? And is there an SDK in my favorite language? How about VS Code? Is there a plugin? And do I always need to do code? Isn't there a simpler way? All these questions and more will be answered during this next 20 minutes. The agenda, the developer portal, networks and nodes, Sandbox, and code. So our developer portal, great place to start. Lots of great documentation, tutorials, solutions, and articles. Also, you'll see a start building icon right in the portal homepage. And that will guide you through to set up your workspace, connect to a node, and do your first transaction, as well as build applications. These are the Algorand networks: betanet, testnet, mainnet, and private networks. Testnet and mainnet are in parallel for the protocol versions. The idea is applications work in testnet, and they'll work in mainnet as well. Private networks are like personal networks. They run on your machine locally. Nodes, you can create your own. And what is a node? Basically, it's your copy of the ledger, and you can have it locally and program against it. You'll need the node address and the node token, typically. Now, you can install a node on a Mac, Ubuntu, other Linux distros, example, Raspberry Pi, also Windows. And this used to take several hours, but now it's fast, and catch-up is here. PureStake and Rad Labs API services is another choice. These are fully indexed archive nodes and accessible from SDK code. That's good for mobile apps too. You can't have a local host running on a device. You can access one of the stand-up servers here that PureStake and Rand Labs offer up. Sandbox is really easy. It's a Docker instance, not for production, and it's basically the quickest way to get up and running to do development work. So basically just clone the repository, install Docker, and you're up and running. Sandbox up will bring up the private network, which includes Indexer. And then you also have support for testnet and mainnet as well. There you see the address for AlgoD and the token and Indexer to do searches. Code tools, lots of tools here. Languages, we got PyTeal. Teal is the name of the smart contract language. Stands for Transaction Execution Approval Language. You also have Reach, a great tool to build solutions with JavaScript and actually other languages now. And the key there, you can deploy to multiple blockchains with the same code. So you can write solutions for Ethereum, for example, and Algorand at the same time. A lot of SDKs and lots of IDEs. Now, the part that's circled in red here, those are built by Algorand. All the rest you see here are all in the community. So let's take a look at a demo on creating accounts. All right, time for our first demo. Let's go ahead and create accounts, dispense funds, and do our first transaction. Okay, our first demo is going to create accounts. We're going to do this in Java. And the idea here is we're going to create some accounts that we can use in our code. So we hit my breakpoint, and we've created 3 accounts. You can see them down below in the output window. And the very first thing you want to do is take that account and then go populate it with some algos, because transactions require transaction fees, and that's the case on testnet as well. Also, you'll see there is a passphrase that's generated, several words that could be used as a private key to populate an account and get the signing key. So there's the dispenser, and this is how you would do it. You just simply paste in that address, and now funds are dispensed to it. And then you can always check that by copying the transaction number and bringing up one of the browsers and pasting in the address here, doing a search, and there it is. That's actually the transaction address. And then you can see the sender and the receiver and then the amount. So you got 100 algos now in that account. All right, the second example, also in Java, is going to be doing your first transaction. So here, we're going to go ahead and print off the parameters. Those are used as an argument into the building the transaction. You can see things like the consensus version, the last round, the minimum fee, and things of that nature. And this is going to go ahead and do a pay transaction. The next step is to sign it. And you'd be signing that with the sender account. So it would be signed with the my address that we have in the transaction. And then also, this is the important part, doing a raw transaction. And this will send out to the network. So now the entire blockchain will see this. And there will be a wait for response confirmation there that gets executed. And once it gets done, you'll see it's been confirmed in a round number. And then we print off the transaction information as well. You can see in this example, I'm also using a note field, and we're going to decode that here and print that off on the display as well. And you can see that right down here, the hello world. Note field is free form. You can put any structure you want in there whatsoever and use it any way you fit. So the next thing we're going to take a look at is Algorand, the IDE, as well as stateless smart contracts. In doing so, I'll actually show you the same thing and how to create accounts inside of Algorand, and also we'll do an example of a smart contract too. So here's our project in Algorand, and what we can see on the right side is the Algorand Explorer with the local SDK installed there. So that facilitates using Goal, a command line tool. And we have nodes set up here. One's for pure stake. There's a local node, and you can wire it up to testnet and mainnet. And it's very good in terms of just all you got to do is hit add Algorand node and put in the server name, endpoint, and the API key. And that's it. Now the code we're looking at is actually a smart contract. This is TEAL, Transaction Execution Approval Language. And this is a very simple contract. The receiver must be equal to Bob's address here, which begins with WCM. And the amount of the transaction needs to be under 10 algos. This is a micro algo, so 10,000 micro algos. It looks like there's 10 algos. And that's the logic that's involved. So the way we do this is we got to look at some accounts here. So let's go ahead and bring up, first of all, let's create a new one. Show how easy this is. Test account. And there it is. And there it gives you your mnemonic. And that's a little bit easier than doing it from code, I'd say. And then also, let's list the accounts and see who we got here. So now we can see we've got that test account that I just did. If you want to see what the balances are on these, you can see these last few don't have any algos in them. So what you would do is just copy that address, go out to the dispenser, and dispense some funds there. But what we're going to do in this next example, we're going to send algos from Alice to Bob. And so Alice is going to be the signing account on this transaction. It's going to be a delegated account. And what that means is it's going to be a stateless contract. And if it returns true and it's signed by an account, in other words, delegated, and then we'll go ahead and approve the transaction. So let's see how this works. So I'm going to go ahead and click on the TEAL program right here. We're going to bring up Algorand and stateless contracts and create what's called a logic sig. In other words, a logic signature. There's two types, a contract account and delegated, which are really the same. The only difference is the delegated needs a signing account, and that's going to be Alice. And that's it. That's all we got to do there. So that generated my LSIG. And now what I'm going to do is go ahead and send a transaction. And so here we go. There's the sender, the receiver. Let's pick a different account to go to. Maybe we want to try to populate that test account. And let's send 10 of these. And what you should see is a failure because it's not going to Bob's account. And the logic will return false, and it does. So it says stateless contract has failed. So let's try that again. And this time, we'll do it correct. We'll go ahead and have the receiver set to Bob. And we'll put in an algo amount that satisfies our criteria of being 10 or under. So let's go ahead and do that. And now what we'll see is the transaction was successfully sent, as well as what we're going to see is the transaction be broadcast to the network like we did before. So a very visual IDE. This is great for developers, it's great for learning, just great, period. Tremendous. And this was developed by the community. The next thing we'll take a look at is multi-sig and atomic transactions. All right, the first one we're going to do is a multi-sig transaction. We're going to do this in Python. So we hit our breakpoint here to create the multi-sig. And a multi-sig contains of a threshold and a list of accounts. So here we got two accounts, account 1 and 2. We're going to actually send in this demo to account 3. We've restored all the accounts right up here using the mnemonics. Once again, this is really only for demo purposes. You would never put actual secret keys in source code. You do utilize one of the wallets to do all the key management for you. But for simplicity's sake, we have a threshold, and we're going to set this to 2. So we're saying both of these accounts that are in the multi-sig need to assign it. Now you can list additional accounts. You can have 5 accounts, 10 accounts, whatever, but at least 2 of them would have to sign off. All right, so there's our address and our token in the code. Here we're going to instantiate the client so we can do some REST API calls through the SDK. We're going to go ahead and get params like we've seen before. And there's the payment going from the sender to the receiver. Now we get to the multi-sig part. So what we have here is an account. This is going to be the recipient. That's account 3. The amount we're sending is 10,000 micro algos. And this is going to take both of those and sign them. So we're going to sign it with private key from 1. We're going to sign private key 2 for the multi-sig. So now we got the required minimum that meets the threshold. And then we'll go ahead and send the raw transaction right there. So the multi-sig transaction will take care of that. And we should see it succeed down below. There it is. Everything comes out. There's a private key from the first one, private key from the second one, and then you have the transaction account. The next example we're going to show you is atomic transfers. We're going to use this in Golang, equal opportunity employer, in all of the languages. So what an atomic transfer does is it wraps up multiple transactions, and they either all have to work or none of it will work. So we're going to go ahead and populate our mnemonics and accounts here again, and we can display the account information that we just did right over here to the console log. And you can see this first one ends with a 6206 right there. Now the first transaction you see right here, we're going to do from account 1 to account 3. And we're going to send 1 algo. On account 2 to 1, we're going to send 2 algos. So this is the second transaction. Both of these must succeed. Go ahead and run. And we see the group ID now gets assigned for both of those transactions to tie them together. And then we sign the transaction. Take a look at the results down below here. Next up is PyTeal. It's a Python library. So you write your contract in Python, and then you compile it out to Teal. So flow to create a brand new application, let's say, that is a stateful application. You might use PyTeal, generate the Teal, and then compile the Teal and use that as a parameter for the approval program when you're creating an application. On the debugging end of things, I want to look at 3 things: the accounts, signed transactions, and the approval source code program. Those go into what's called a dry run request, and then you can go ahead and debug that with Teal Debugger. And that's a Chrome inspect, allows you to set breakpoints, step through, look at both global storage and local storage that's associated with that. You can also set breakpoints there. Use your own indexer in Sandbox. You would just do Sandbox up. So indexing service is available. And also you do have to query that now. And you won't have any explorers available in the private network. Those are only available for testnet and mainnet and betanet. So what you would do is use curl commands or postman REST API calls to verify. Now we do have a run in postman button in the documentation. Just click it and pop up postman. What we'll do here is the base URL is set to go against the Sandbox. And now I just hit the send button. The only thing I did differently here was I just pasted in the account we want to look at. And this is useful if you see the response that returns back. You can see you have course, the amount of the account. You have assets, and the assets that you have here are the ones that are being consumed. So this account uses this asset ID that ends in 5366. But also, and that's related to the account, would be the apps that are created. So this would be that approval program that we looked at in the last few slides. This is what got created, and it's part of that particular account. And also you would have created assets. And assets, this would be the information that's associated with that asset, the clawback, the creator, the decimals, the freeze manager, and all that. And if you had apps that were consuming the smart contract, you would have additional information there, just like you have for those that use the assets. You would have items that in here that would be using the application. They've opted in to participate. That brings us to the best developer newsletter in the world, Algorand Developer Newsletter. Just go out to our developer portal and click on the newsletter at the bottom. And community projects. What a great community is being built around the Algorand technology stack. We have a page really dedicated to this up on our developer site. I encourage you all to look at it. Highlight a few of these. One is Reach. This is the safest and easiest way to build applications. You can build applications for both Algorand and Ethereum at the same time with the same base code. Just a setting change on deployment is all you need to do. That's in JavaScript, and they have other languages available now too, Go and Rust and a few others. And so that's the programming language. The compiler then generates the correct code, the correct smart contracts per the environment that you want to deploy to. The MetaMask, like Chrome Wallet, the Algos signer has an API. So if you want to write like web-based solutions that use the key management in Algos signer for the private keys, you can do that. So that's more of a real-world scenario, being able to utilize that in your application. We have videos on all these. The links are there. I'll have the link to this deck at the end. My Algo Connect, very similar in the idea that you just saw there, but it's not an extension. It's actually a web application. You can go ahead and integrate your web-based solution with the private key management in My Algo Connect. The Algo D is great. I think this is something you want to load up first out of all the community tools. This is the most productive that you'll see there. A lot of great reward programs. So yeah, we're paying developers to do things, right? The Algorand Foundation is a separate company from Algorand Inc. It is responsible for token economics. Algorand Inc. is the company I work for, and we are primarily responsible for technology. But in any event, the foundation has provided incentives, and there's a developer rewards program. There's a developer ambassador rewards program. That one there, you can write content for our developer portal and be rewarded for it. Also, there are grant programs for larger projects. There's a list of grant recipients there and a few other resource links as well on Algorand Scouts and Security. The ambassador program is growing very large, over 500 ambassadors in 66 plus countries. Contact Stephen at algorand.foundation. Great video resources. YouTube channel is youtube.com/Algorand. There's a couple of videos there on Teal and Pure Proof of Stake. And we got lots of code samples for you all over the place. So just refer to this deck and you can find them. Typically, when you look at the developer portal at the bottom of the tutorial, you'll see a link to all the code and you'll be able to find it there. At the bottom of the feature, you'll see a link to the code there. So in summary, developer portal rocks. It really is a great way to develop apps. A lot of information there. Networks and nodes we covered in terms of you can do a private node, you can do a node basically that is available through API services like PureStake and Rand Labs. The Sandbox, a great way to get going up quick. You don't have to build your own node. You can just use the nodes generated there. That is primarily used for testing purposes. However, you can bring up mainnet, say you have a problem you want to troubleshoot, you can go ahead and do that, but really it is geared toward testing. Code, we saw a lot of SDKs, and also there's some great community SDKs on C#, and I just found out today community has also created a Swift SDK as well as a Unity asset plugin, which is pretty cool. We'll have more information displayed on that in our site, and we'll get that information to you. That's hot off the press at the time of this recording. Here's a link with the PowerPoint as well. I encourage you to join our Discord channel at the top and additional resources here in the deck. And that's it. I want to thank you for attending. I hope you create a killer blockchain solution. Thank you very much. Russ Festino signing off.